Sun's starting to shine down here on the U of I quad. We're here for back to school, the first day of class on the U of I quad. And of course, our wise guy is here with us. Just stepped out of his office. Wise guy Matt Sullen here to give us a little bit of the physics of some of the things we're going to see here. Of course, a lot of people are out here playing catch, playing frisbee. You see that throughout the semester.
Oh my goodness, you should have seen it yesterday. There was quad day. There was thousands of people. This place was wall to wall, and there was a lot of physics going on even because we had the physics van out, which are my students. But anyways, today's a big.
There's always
that's right.
Going
that's
on,
right. Of course. Well, today's a very big day because my first class is at 8:30 this morning. So as soon as I'm done here, I'm going to run over there like crazy.
Right.
So anyways, it was actually Matt's idea, and I have a feeling that he's an ultimate frisbee player or something because he wanted to hear about how frisbees work. So I said, yeah, fine, I'll bring a frisbee, and I brought a ball too, so we can illustrate the difference between frisbees and balls.
Aerodynamics here.
Aerodynamics, exactly right. When you chuck a ball, and I'm going to throw this to you.
Okay.
Okay. When you do this, the motion of that thing is very simple. It goes up, it comes back down. It's a very simple parabola. When you throw somebody a frisbee. That was pretty good. Okay, what you see is the frisbee kind of hangs a little bit. It behaves more like a wing.
Jump as much, it goes across.
That's right. It has lift. Okay,
so
and the way
toss it back here.
Right, and the reason for that is that the interesting shape of the frisbee. It's shaped kind of like a little bit of an upside down dish. In fact, I think they started out by throwing pie plates or something. That's how people invented frisbees. And so what happens is, as you throw this thing into the wind, you know, the air kind of cuts underneath it like this, and the air also slides over the top, and the air gets directed sort of downward as it passes over the frisbee. And if something gets directed downward by Newton's third law, which is action-reaction, the frisbee gets deflected upward. Okay, it's like a little airplane wing. It's exactly the same thing. And the reason you spin the thing is that things that spin have stability. If you try to throw a frisbee without spinning it, it just does that.
It's down.
Okay, if you spin it, it's very stable. Okay, all right, and
so it's kind of got a little orbit or a little something there.
That's right. And if you try something very interesting, if you try to throw a frisbee upside down, it doesn't work at all.
Right.
And I tried this yesterday. I was driving down the road in my car. I stuck my hand out with the frisbee in it like this. Okay, and if you hold it like this, when the air is rushing this way, you get a lot of lift. If you hold it upside down, you don't get very much lift at all. You can try this if you're moving kind of slow yourself. Right. And so I'm going to throw this frisbee now because I like to do this. Okay. And maybe that guy won't even know that it's going to hit him in the back of the head. Let's see.
Oh my gosh, it's gonna.
Hi. So anyways, there's a lot of aerodynamics in a frisbee, and when we come back in the second segment, I want to talk about how it behaves a little bit like a gyroscope too. Okay. So how it can go one way or the other because of gyroscopic precession.
So who knew there were physics happening out here? You did.
Oh my God, of course.
Matt, thanks for being here this morning. We do appreciate it. Matt Sullen, the wise guy, we're on his turf this morning, and boy, what a beautiful morning it is to be out here. Robert, I bet you wish you were